that is due tomorrow. And we did go over question 1 through 5 yesterday. We will pick from question 6 at the end of the session if you want me to review any of the previous questions because you still did not understand it. You definitely can ask questions and we can go over those questions again. And this is question 6 and this is where we pick from. Remember, when you take the progress learning quiz, the questions will be shuffled. Your question 6 might be a different question, and that is okay. You should know how to solve the questions. You don't have to remember which order the questions were in. Okay, this is question 6 for our Nearpod, and the question reads, Nicole has 2 bags of coin. The first bag contains 5 silver dollars, 4 quarters, and 6 dimes. So this is the first bag. The second bag, I can use a different color. The second bag contains 2 silver dollars, 3 quarters, and 2 dimes. Nicole is going to let her little brother, Jacob, randomly select and keep 1 coin from each bag. What is the probability that Jacob will choose a silver dollar from each bag? As you are thinking about how to answer the question, make sure you're thinking about whether you consider this as a simple event, like one event, or do you consider this as a compound event, right? Important to consider. Go ahead, people, get started at this point. My eyes are on your Nearpod slides to give you feedback. Everybody, get started. Join Nearpod. Link is in the chat, also in the question answer chat. I want to see you here in Nearpod. Very good, Tate, getting started. Derek, very good. Step 1, do you guys consider this as a simple event or a compound event? And why? Please raise your hand to answer. Ava, what do you think? Feel free to type in the chat. Feel free to hop on the mic. Feel free to mark on your slide. Annabelle believes this is a compound event because 2 things are happening. Annabelle, I am very proud of you. Very good, very good. There are 2 things happening. And it will be a compound event. Ava, I received your message. This is a compound event. So first bag. Let's start to jot some information down. We talk about the first bag. First bag has how many coins? First bag has 5 silver dollars, 4 quarters, and 6 dimes. Altogether, first bag has 15 coins. Right? Second bag has 2 silver dollars, so 2 coins, and 3 quarter coins, and 2 dimes. Altogether, they have 7 coins. That is important, right? So Jacob, Nicole's younger brother, chose a silver dollar from each bag, right? And this is where the silver dollars are located. In bag 1, 5 silver dollars, and in bag 2, there are 2 silver dollars. And Annabelle says it is a compound event. In compound event, we are multiplying the probabilities to get the compound probability. Let's see how you guys go about doing this question. Derek, I see your work. Let me see if I agree to it. I'm going to refer to my answer key. I think you're still solving, Derek. Tate, heading in the right direction. So, the probability of selecting a silver dollar from the first bag, is 5 out of 15, right? Because there are 5 silver ones out of total of 15. The chance of picking a silver dollar from the second bag is 2 out of 7. Are there any questions so far? The chance of picking a silver dollar from each of the bag is a compound probability, and that's how you find it. 5/15 from the first bag times 2/7, the probability of picking a silver dollar from the second bag. You multiply the two and you get the answer. I know everybody will have a different way of multiplying, and I have some suggestions to make multiplication easy. If I can reduce the numbers at any point, I will do so. You see, 5 and 15 can be reduced, right? 5 and 15 can be reduced by 5, right? 5 one times is 5. 5 three times is 15. I will reduce it before I multiply so I don't have to handle bigger numbers. Then I can multiply. So I have 1 now because 5 is now a 1 times 2 gives me 2. In the denominator, I have this 3 here. 3 times 7 gives me 21. Therefore, for the younger brother, Jacob, to grab a silver dollar from bag 1 and bag 2 is 2 over 21. I'm going to pause. Are there any questions? Does it make sense? All the following questions kind of follow the same trend. As I looked at those questions before in the morning, before teaching, I saw that all the questions kind of follow this very same trend. So if you understand this one, very likely the rest of the 4 questions you probably know how to do. Numbers are different, context is different, concept is same. Let's go ahead and look at the next one. Okay. Some questions like these will just have fewer more details. Grandma Marilyn has the following ice pops in her freezer. There are 5 cherry, 3 lime, 4 blue raspberry, 6 grape, and 2 orange. When I look at this, my brain goes, okay, I'm going to find how many total she's got in the fridge, in the freezer, right? I'm going to go find the total. It is important. Everybody go find the total and tell me how many ice pops grandma got in the freezer. Please calculate how many total ice pops grandma got in the freezer. It is important. Anytime the number, there you go, Derek, you were fast. What about others? Tate, I agree to you. I got the same. So at least 3 of us ended up getting 20, right? So yes, that is true. Grandma's got total of 20 ice pops in the freezer. So if Grandma Marilyn randomly selects one ice pop to eat, what is the probability in decimal form that she will choose a grape ice pop? Everybody get started. Show me how you will do this problem. If you need further guidance, I'm going to guide you. Derek, you're heading in the right direction. And you want to answer in decimals. That is another thing. Very good, Dion. That was fast. You will realize gradually progress learning quizzes are getting easier. As I was creating the progress learning quizzes, I knew the initial ones were a little harder, but as we go through the semester, progress learning quizzes will seem to be easier to you guys. Very good. So if we want the probability for the grandma to choose grape flavor, we know that there are six. There are six grape flavored ice pops. 6 out of total 20. Right? That is the probability of choosing a grape. You can also simplify the fraction and you can say half of 6, 3, half of 20, 10. Right? You can simplify the fraction and say 3/10 chance of getting grape. Or you can write in decimal, the 3/10 is decimal, 0.3. The computer will not accept anything but 0.3 as the final answer. Very good, Annabelle. Excellent. The computer will remember not take anything but a decimal answer. If you put in something else, it will not accept it. Although you might be right. Are there any questions before we move on? There are students who like to open a progress learning quiz as we answer the questions. If you are the kind of person and would like to save time, you can also do that. Deontay, join Nearpod and show me your work. Let's go ahead and move on to the next question. Okay, Adam, that is a good thing. Very good. Very good, Adam. Okay, here. A cookie jar contains several cookies. There are 12 chocolate chip, 8 peanut butter, 4 sugar cookies. Remember, it's important to find total. It just gives you a better idea about, what proportion each cookie is. Everybody add them up and find the total. How many total cookies do we have? Add them up, find total number of cookies. Tate, there you go. That's what I got in my head. 12 plus 8 is 20. 20 plus 4 is 24. So total number of cookies they're talking about is 24 cookies. So when I know 24, it is so easy for me to tell that chocolate chip cookies are half the total cookies, right? That's why I like to see the total. And I know that sugar cookies are the least. Jace randomly selected a cookie from the jar. What is the probability in decimal form that the cookie Jace selected was a chocolate chip cookie? See how easy the question is for you at this time? Everybody get started. See how you will answer the question. Very good, but in decimals. Adam, there you go, Annabelle. Excellent. You want the answer in decimals. Let's see how you answer. Ava, excellent. Tate, very good. Derek, excellent. Brianna, I want to see your work in Nearpod. Chocolate chip makes up 12 of the 24 cookies. They're half of the total cookies. Or you can say half. But remember, the test wants you to put in a decimal. So half as a decimal is 0.5. Some of you also like to do 0.50. That is also okay. Right? But 0.5 is half. Very good, Dion. Excellent. Are there any questions? All this seems easy to you? Anybody? Angel and Nathan? If there are questions, let us know. Adam, Sanai, Cheyenne, Alex, Zion, Crystal, Deontay, how are we doing? Also remember, if you are confused in any of my sessions, you can always mark one of the colors. I am looking at your slides. I will absolutely go over this again. If I see someone is stuck and has chosen to be on a red color, that is meaningful because I will definitely make sure we make all efforts to help you. We are doing progress learning quiz. Remember, this title tells you what we are doing so precisely. Each time I'm going to do building blocks, I'm going to make sure I have a title on each and every slide. So people joining late will still know what we are doing. Question 9. And here we are. A candy jar contains several small pieces of candy. And we will definitely add them to find total. There are 5 miniatures, 7 dark chocolate, and 8 gummy worms. People, please find total. It is important. Whenever you see these numbers, it is important that you know that is 20. Derek says, I agree too. Derek, I also got 20. There are 20 total pieces of candy. Roger randomly selected one piece of candy from the jar. What is the probability in decimal form that the candy Roger selected was not a gummy worm? So not a gummy worm. Very good, Dion. That was very fast. Let's see how the rest of you do. Was not. Derek? Was not a gummy worm, right? There are 12 that are not gummy worm. Oh yeah, you guys are right. So we will bubble this part. Not a gummy worm is the 12. It's 12. It is 5 and the 7. That makes 12. So probability of not a gummy worm is basically 12 candies. 5 plus 7, 12 out of the 20. That also means if I have the fraction, it is 6/10. And because the question wants you to answer as a decimal, you will just say 0.6. 0.6. If you don't put 0.6, I think the test might mark you wrong. So Annabelle says 0.60, yes, or 0.6, both mean the same. Any questions before we move on? No questions? Very good, Adam. Last question on the progress learning, question 10. Mrs. Taylor, the librarian, has the following puzzles on a shelf. There are 3 puzzles with 1,000 pieces, 8 puzzles with 500 pieces, 4 puzzles with 100 pieces, and 3 puzzles with 50 pieces. Before I go read the question further, you guys know by now, I like to find the total. It just makes the math reading easier and the brain understands better. Go find total number of puzzles that Mrs. Taylor has. Tate, this is what I got. I got 18 total puzzles. There are 18 total puzzles that Mrs. Taylor got. So Lola will randomly choose one puzzle to put together. Very good, Annabelle and Adam. What is the probability that Lola will choose a puzzle with 1,000 pieces? What is the probability that Lola will choose a puzzle with 1,000 pieces? Very good, Ava. Very good. Derek, I'm waiting to see how you answer. Cheyenne, people in the chat, Annabelle, Adam, Deontay, I am waiting to hear from you. Zion, Crystal. And that means they are referring to puzzles with 1,000 pieces. And we see that there are 3 puzzles with 1,000 pieces. So we can say it is 3 chances out of 18 total. In your progress learning quiz, you will see no answer will match this. Very good, Annabelle. Excellent. Therefore, it is important you reduce the fraction by 3. 3 and 18 can be reduced by 3. And then you will see the answer will match with one of the 4 answers given. And then we can say that 3/18 is the same as 3 divided by 3, 1. 18 divided by 3 is 6. 1/6. The probability of choosing a puzzle with 1,000 pieces is 1/6. Are there any questions? Let us know before we move on. Welcome to class, Nolan. Adam says no questions. Adam is dismissed. If any of you have a question over a question I already covered yesterday, let me know so I can cover them. Otherwise, this just mark the end of today's math building blocks. Remember, Miss Said's going to be out of office in the afternoons. So if we end any time sooner than the time we anticipate, that is good. Absolutely, Adam, you are dismissed. I'm going to wait and see if anybody still has any questions before we end the session. We definitely want you guys to be successful on each and every assignment for my class and pass the class with flying colors. Annabelle, really pretty hair bow thing. Very good. Nice. No questions? Let's see. It's maybe one in the question answer chat. I'm very proud of you, Ava. Okay, Cheyenne. We move on to question 1. And as I scroll through the questions, look at them carefully. Maybe your question looks different from mine. Right? Your question 1 might look different from mine. So I'm going to scroll slowly. You look at them carefully. Annabelle, I'm very happy to hear you made the hairband yourself. Nice. Very creative. So Cheyenne, look at these questions. See which one you need help on. There were some questions we went over yesterday a little tricky than the ones that we went over today. This is question 3. Or you can read out the main key person's name and tell me. I can search for the question and make sure we go over the question you want. But Cheyenne, for myself, this is question 1. Is this the question you want? This one? Okay. So the table shows the number of different kinds of drinks sold during breakfast at the Banquet Middle School cafeteria on Wednesday. And yesterday, as we went over the question, we tried to add these up, that there were 10 apple juice, 24 chocolate milk, 7 orange juice, 13 strawberry milk, and 6 white milk. And the total, as we added, we got 60. And these numbers are for Wednesday, right? If the Banquet Middle School sells 120 drinks during breakfast on Thursday, which prediction for Thursday is not supported by the data in the table? We also know that on Thursday we can use a different color. On Thursday, now I'm going to represent Thursday with a T. They sold 120 drinks. Using the numbers in the table, can we predict how many of each kind of drink was sold on Thursday? This is question 1. Yeah. Using the information in the table and the totals, can you predict the kind of drinks that were sold, each kind of drink that was sold on Thursday? Cheyenne? Make predictions, people. Predictions will make an important part of 7th grade curriculum. You'll see a lot of assessment questions want you to make predictions because the main purpose of math definitely is to make predictions. If I see the total is twice from Wednesday 60 to Thursday 120, I can safely assume that all these numbers also have to be doubled. Therefore, on Thursday, I can maybe predict that 20 apple juices were sold and 48 chocolate milk and 14 orange juice and then 26 strawberry milk and 12 white milk. Right? Because I doubled each of the numbers. Now, I can definitely, it makes it easier for me to find the answer. And I am looking for not supported. I can say I'm looking for false statement. I'm looking for a false statement here. Read the 4 and see which one seems to be a false statement. Okay, Cheyenne? Read these statements and see which one seems to be a false statement. Welcome to class, Nick, Ayani, Amy, Bella, David. I'm glad we didn't end the session and you get to go over this question with us again. For those questions we already went over, you can also refer to the recordings because you guys joined a little late. Okay. Let's look at each and every answer choice. Welcome to class, Derek. The number of cartons of apple juice sold, right? The number of cartons of apple juice sold, and here is apple juice, will be 3 times the number of cartons of orange juice sold. So, right, from apple juice to orange juice, is it 3 times? Is apple juice 3 times the number of orange juice sold? This seems to be false, right? Because it is not 3 times. Cheyenne, B, let's look at B. There will be 86 cartons of milk sold. And the milk, this is the one that tripped us yesterday, Cheyenne. So they didn't mention which kind of milk, they just said milk. So let's see, if you look at the milk, we have chocolate milk, right, 48. And we have strawberry milk, that is 26. Then we also have white milk, that is 12. And the numbers are big enough, right, to safely predict that maybe 86 cartons of milk was sold. Remember, it is a prediction. So this probably ended up giving us, so 48, 50, 60, 76. This gave us a total of 76. But this, I can still say it is a good prediction that 86 cartons of milk were sold. It is not so way off. Maybe they're not saying just 6 cartons of milk were sold. The prediction says 76 were sold, but until if 86 were sold, it is not so way off, right? So I wouldn't still say that this is so wrong, but I would still put it towards the true side, not too off. C says the number of cartons of apple juice sold will be 6 more than the orange juice. So let's make the comparison. Apple juice and orange juice. Is it 6 more? Yes. From 20, prediction of 20 to a prediction of 26, it definitely is 6 more. This is just predicted, and that seems quite true. Then we look at D. number of cartons of chocolate milk sold will be 4 times the number of cartons of white milk sold. So if we have white milk as 12, is chocolate milk 4 times? So white milk to chocolate milk, right over here. Do you think that chocolate milk is 4 times the number of white milk? Yes, it is true. Why? Because chocolate milk is 48. And that is 4 times of 12. 12, which is white milk. Right? So it is true. Another true statement. We were looking for a false statement, and A was that false statement. Very precisely the false statement, because it doesn't seem to be no way a true statement. Are there further questions you guys have that we can answer? Yes, Cheyenne, these questions will require some amount of reading. I could really direct you to the answer much faster because we looked at it yesterday and we were arguing whether B is true as a false statement or A, but we kind of concluded that A seems to be more of a false statement. Welcome to class, Kennedy, Emiliano, Valerie, Nick, JJ, Milo. If there are questions, let us know. If not, we went through all the 10 questions for the progress learning that is due tomorrow. If you want, you guys can also watch the class recordings. I am going to publish the recordings in like around 15 minutes because they won't be ready before then that. I tend to share the recordings also in the grade book. If you go to math and go to grades, all recordings are also housed over there, so you can easily. JJ, if you use the same link after 15 minutes, you will get to the recordings. I do not have the link to the recording at this time because the recording is not even ready. Okay, but I will definitely share the recordings. I'm going to share the recordings after 15 minutes because that's how long it will take to publish. We already completed all the questions, JJ. We will end the building block session here. But if any of you have any questions, I'm going to still pause and I'm going to make sure I answer your questions before we end the session. If there are no more questions, we end the session here, right? Thank you so much. Okay, here I see Derek has a question. I will post, Ayani. Can I go over the B one again? Absolutely, Derek. B says, as per the predictions, as per the table, we can predict 76 cartons of milk to be sold. This is as per the table. And this statement says that there will be 86 cartons of milk sold. They are saying 10 more than what we predicted. It doesn't seem to be like so wrong because they didn't go so off. They're not saying something as low as 6 or they're not saying something as high as 200. But they're saying something around what we predicted, right? Our prediction was 76. And therefore, I didn't consider it to be a fully false answer. Okay, Derek R., that is why. But A is like a clearly wrong answer because it says 3 times that apple juice cartons were 3 times the orange juice cartons, and that is just so false. It is not true, right? If you multiply the 7 times 3, you get 30, not 10. So why do we only count Thursday? Because we want to make a prediction for Thursday. Here the statement says, Derek R., they gave you information for Thursday and they want us to make a prediction for Thursday. That is why I was only considering the Thursday information from this table. Right? Look at this part of the question. They told us about Thursday and they want us to make a prediction for Thursday. Perfect. Thank you so much for joining. I'm going to see you in class tomorrow when we will take the progress learning quiz, and I'm hoping you all will do good. If there are further questions, feel free to send me an email.